Okay, so we are coming back from the break. Here, we talk about how to read English. I mean, especially those long paragraphs, long pieces of English. But the content, what does it say? It talks about how to add these three forces together. Because if we add two forces together, if we add two forces together, and if we add two forces together, that we can use we can use trigonometry to add the two forces together to get the resultant. But if we want to determine the resultant of three or more forces like this one, we cannot use this one anymore. We cannot use this one anymore for this one. So the best way to deal with to determine the resultant of three or more forces is to break it down into I and j into different components, and then we add the separate components together, and at last we can get the resultant. And these are the three steps. These are the three steps describing the how should we do it. And at the end of the paragraph, it says the procedure is described will be carried out most efficiently if the computations are arranged in a table. Efficiency is this one, and table is this one. So we will do it in this way. Let's try. So we come to sample problem 2.3. In this sample problem, we are adding four forces together, and what do we determine? We determine the resultant of the forces. We determine the resultant of the forces. So we have four forces here. Because the resultant is not because the figure only shows the four forces but not the resultant, we need to give the resultant a name. Therefore, we have let the resultant be R. Okay, we give the resultant or the answer we want to find a name. We give it a name. We have four forces here. We have four forces here. Therefore, naturally it is equal to F1 plus F2 plus F3 plus F4. These four forces, we have four forces, and we cannot use trigonometry. We cannot use sine and cosine to determine the resultant. And as we just discussed, we can use a table to arrange these things to get the resultant. First of all, this is step one, right? Step one is this one. F1 to F4 are resolved into horizontal and vertical components. Horizontal and vertical, we talked about this words just now. I mean, before the break. Before the break, we talk about what is horizontal and what's vertical. Horizontal is this one, and vertical is this one. And resolve into means breaking down. This one means breaking down. So if we are okay with this understanding the questions, and we understand how should we do it, so we fill in the table now. Now we have F1 to F4 listed in a table, and then we have the first column. The first column is the force, the name of the force. These are columns. And these are rows. So we have the first column is we write down the symbols. The second column we write down the magnitudes. The third column write down the angle. Write down the angles. Let's begin with F1. F1 is this one. F1 is this one. So it has the magnitude of 150 newtons and its angle is 30 degrees. So 30 degrees. This is simple enough. F2. F2 is 80 newtons. Also clear enough. But how about the angle? It gives this is 20 degrees, but be careful if we use I and J. I is this direction and J is this direction. And the theta is always this way and starting from the right hand side. If we use I and J. Therefore, the angle is 110 degrees. Is that okay? For F3, F3 is going downwards. So the angle is from 0 to 90 to 180, and then here is 270. Okay, from the right is do we have it? Oh, yeah, this one. This one's clearer. So we have 0 degrees and then 90 and then 180 and then 270 here. And then the last one is 345 degrees. After you know the magnitude and you know the angle, of course you can determine the components. X component is equal to F cosine theta and Y component is F sine theta. I think you can handle this. I think you can handle this. And so 150 newtons times cosine 30 degrees is 129.9 Newton, 129.9 Newton, and F sine theta is 75 Newton. And then you do the rest, okay? You do the rest, or you check the textbooks to write down the rest. Anyone of you have got your textbook? Can you raise your hand? Anyone of you have got this one? Good. And I will talk about. So I will let you know. I will talk about. I'll talk about what I will cover on Thursday later on. And I assume you know how to. Okay, you got the old one. This is good. There is no problem of getting the last one. The last one is. Have I got the last one? The last one. Oh, I don't have the last one is not. It's not with me. No problem. So the last one is okay. The 11th edition is okay. Now, and for our. So after you fill in the table, I think you will get you will get these two. You'll get these two, because we have addition here, right? We have addition here, right? And then we add this, and the sum is this one. We add this, and the sum is this one. I assume you are okay with this. Next, we have we can write down the resultant. This is the resultant. For me, I am okay with this answer, but there are some professors they don't like this answer, as I have mentioned. As I've told you, let's go back to page 5. On page 5, I've said that I'm fine with I and J, but there are some professors who are not okay with I and J. They think it is not good enough. Therefore, let me do it. Let me put it in their way of writing. I'm okay if you write this. Okay. Next one is if we want to write it in their way, we need to determine the magnitude and phase. This one is equal to 199.6 Newton and angle. So R is equal to 199.6 Newton. Angle is 4.1 degrees. So is this okay? Any problem with this sample problem? I will give you a couple. I'll give you a couple of minutes to write it down. For these boxes, for the empty boxes, I expect you to do your own calculations and fill them in, or you can check the textbook. I think it has the. I think it's on page 33. Okay, the answer is there. So the next, if you are okay, that can you raise your hand? Okay, thank you, and you may you may lower your hands. Let me give me a minute more, and oops. Okay, we come to the next next topic, since we know how to add many forces together. Equilibrium of particle. Equilibrium in the, of course, in chemistry it means something else, but here it means this one. Equilibrium is related to Newton's first law. And it means the resultant of all forces acting on a particle is 0. It means this one, equilibrium. it means the total force is 0. The resultant means the total force, right? Total force of all forces acting on a particle is 0. If so, next we have an example. In this example, we have 4 forces: one going to the right, one going to upper left, and one going to lower left, and one going downwards. We have 4 forces. If these 4 forces are in equilibrium means it is pronounce this one equilibrium. We have 2 ways of expressing equilibrium. The first one is the mathematical expression. Mathematical expression, it means if we add all the forces together, it is equal to 0. This one is called the summation. If you have all forces added together, it is equal to 0. In English, it's simple means summation. It's called summation. And in graphical expression, in graphical expression, we have we can put one force after the other. There's F1, and then we have F2. Oops, F2 is here, and then we have F3. And then we have F4. And because we put one factor after the other, F1, and then we have F2, and then we have F3 and F4. If the sum of these 4 forces is equal to 0, it means it goes back to the point where F1 is when F1 begins the journey, right? It begins here, and then it means it goes to return to the same points where F1 began. So it means it is we call it a closed polygon. In Chinese, is this one. Is that okay? In mathematics, that it means summation of F equal to 0. And in graphical expression, it means if you put 1 force, 2 force, 3 force, 4 forces, 1 force, 2 forces, 3 forces, 4 forces, we come to the point where we begin the addition. So it is a closed polygon. Closed polygon here. Please raise your hand if I can go on, if I can continue. Please raise your hand if I can go on. So I will ask you like this in the future if I can go on that. I'll ask you. As I mentioned last time, that note taking is very important at university. At your university study, you can ask me to go slower, but I will expect you to do your own note taking. So anybody wants me to have a few more minutes, you can use other signs to let me know. So okay, then yeah, you can lower your hands and I will go on. Thank you. You can lower your hands. Now we come to another word. Another thing. Another thing we talk about or you have learned at high school, which is called the free body diagram. Free body diagram is this one. And I mentioned at the beginning that if for some problems you must draw the diagram. Here is it. You must draw the free body diagram if the for problems or calculations of before calculation involving equilibrium. If it means if in any problem involving, if there are any problem that you need to use this equation, you must draw the diagram beforehand. Okay. If you are working on any questions in examination or in quizzes that you use this expression, you always need to draw the figure beforehand, or you will lose 1/3 of the mark. At least 1/3. Okay, and so it is a this is on page 39 of the our textbook. It shows. Let's go. I think we don't go. We don't go to the verse first. We go with the with a person. Okay, with a person standing on the floor. So we draw the free body diagram of the person. Or should I? I think I should cheat a bit and then we can draw it better. Right. Okay. So we have a free body diagram here. We have a free body. We want to draw a free body diagram. How should we draw it? Of course, we draw the person. We don't need the floor. Okay, we don't need the floor because we are drawing the free body diagram of a person. What should I draw next? You can leave. You can say in Chinese or say in English or write it in the box. I think you have learned gravity. Good. And then we have gravity here. And we draw mg, right? Mg. But we don't have equilibrium because the forces here are not equal to 0. So what should we do? Does anybody know? So because your feet are touching the ground, so the ground would give you reaction good R1 and R2, and good, and this one's reaction okay, very good. So I think this for this problem very good, and so we have it is this is our free body diagram. Of course, we have more difficult or more complicated or more complex free body diagrams in the future, but for today, I think we will have let's do it like this. And so in words, the first one is show a free body diagram shows all external forces acting. Remember this, all external forces. You are not showing some of them, you show all of them. Acting on a particle or body. Second thing is, if there are any two things are in contact, it must have a reaction. Okay, for example, if the person and the floor are in contact, if the person and the floor are in contact, that they must have reaction. Or there are forces. It's okay. So let me stop the recording here, and because I think this is more or less I can do today.